Alright guys, yesterday we learned how to do laws of exponents and we reviewed all the rules. Today we're going to review solving exponential equations. So there's just one little rule today, and our rule says if b to the x is equal to b to the y, then x equals y if or for b cannot equal 1. So here's what that means. When you're solving an exponential equation, if you can get like bases, then I can make the two exponents equal each other and solve. So let's look at an example of what I mean. So number 1, let's do 3 to the 8 minus x is equal to 27 to the 2 minus x. So first of all, I know that these are both exponential because I have a variable in the exponent. I know I could solve this if I can get like bases. So I know that I can rewrite 27 as 3 to the third power. So I'm going to go rewrite this as 3 to the 8 minus x is equal 3 to the third to the 2 minus x. Now that I have like bases, I can take my two exponents and I can make them equal. So I can say 8 minus x is equal to 3 times 2 minus x. And then it just becomes a simple algebra 1 problem. So I distribute my 3. I add 3x to both sides. I subtract 8 from both sides. And I divide by 2, and x equals -1. So again, your goal is to get like bases and then set the exponents equal to each other. So do another one. Example 2. Okay, example 2 is going to be 3 to the 4x is equal to 27. Okay, again, my goal is to get like bases. So I can change 27 to 3 to the third. So now that I have like bases, I can set these two exponents equal to each other and say 4x equals 3, x equals 3/4. Easy peasy. Alright, let's do another one. Number 3. Let's do 2 to the x squared equals 16. So this time I'm not going to have a base of 3. I can tell I'm going to have a base of 2. So 2 to the x squared equals 2 to the 4th, because 2 to the 4th is 16. So now I can make these two equal, and I get x squared equals 4, x equals plus or minus 2. And we're done. See, this isn't too bad. Example 4. And I have 4 times the square root of 32 is equal to 2 to the 3x. Alright, so this one's a little trickier. I can tell, though, that I'm going to have a base of 2. So I'm going to try to write everything in base of 2. So 4 can be written as 2 squared times the square root of 2 to the 5th equals 2 to the 3x. Alright, now I want to, even though I have the same base here, I want to be able to combine them. So I'm going to go rewrite this as 2 squared times 2 to the 5 halves. Because remember, the denominator is the root and the numerator is the power. We learned that rule yesterday. Okay, so I'm getting there. Now I need to combine these two. Because I'm multiplying, I can add my exponents. So I'm going to come up over here. And if you add 2 to 5 halves, we end up with the 9 halves. We have 2 to the 9 halves equals 2 to the 3x. So let's talk about how we got 9 halves in case you didn't see it. I put this over 1. I'm going to multiply top and bottom by 2, so that'll change to 4 over 2, and 4 plus 5 is 9. Alright, so now I have like bases. So I'm going to set these equal. So 9 over 2 equals 3x. I'm going to divide by 3. So I'm going to have x equals 9 over 6, which is going to reduce to x equals 3 over 2. Okay, got one more example, number 5. Alright, so on number 5, I have 1/4 raised to the negative 2x equals 1/8 raised to the negative 3. Again, we're trying to get like bases, so I'm going to go rewrite these two in a base of 2. So 1/4 is the same as 2 to the negative 2, and 1/8 is the same as 2 to the negative 3. Alright, so now I can just go and say like bases, and I can set these equal. So we have 4x equals 9, so x equals 9/4. Okay, and that's it. That's how you solve exponential equations.